In the planning of a barge towing operation, the specifications of the tug and the barge must be considered. The boatmaster must ensure the vessel's age, size, horsepower, capacities, limitations, etc. are suitable and adequate for the intended cargo and voyage. He must ensure that the tug, barge, and crew certification comply with required standards. The boatmaster must ensure that the tug's crew is familiar, adequately trained, and equipped to handle the risks associated with certain types of cargo. The risks to consider should include stability risks of cargo shifting, or risks associated with the class of the cargo in the International Maritime Dangerous Goods Code. The boatmaster must plan the intended route to ensure risk exposure, in relation to piracy and/or sea conditions, is controlled. To ensure the crew, vessel, and related equipment are all in satisfactory condition, and able to undertake the intended voyage safely, vessel suitability, and the towage plan are approved by an independent surveyor. The first factor that determines whether a tugboat will push or pull a barge depends on where the tow is happening. In many situations, a barge being moved across the ocean will be pulled using a tow line because there's so much open space involved and not a lot of precision that's needed. If a barge is being moved into a harbor or a tight passageway, on the other hand, then it's often better to push it. The master's line of sight should not be obstructed by any part of the barge or its cargo. The design of a tugboat is the most important factor in deciding whether to push or pull a barge. The condition of the tug's fenders will factor into the decision of whether a barge will be pulled or pushed. It is recommended that the towing winch brakes should have an appropriate static holding capacity to that of the documented minimum braking load of the largest tow line to be used. The holding capability should be calculated for the outermost towline layer on the winch drum at which towing will be performed. The design and scantling of the towing winch, especially its supports, should be capable of withstanding the braking load of the main towing wire rope without permanent deformation. It should be possible to release the tension on the winch drum in an emergency, and in all operational modes. The end attachment of the towing wire rope to the winch drum should be of limited strength, thus forming a weak link in case the towline has to be run out. After an emergency release, the winch brakes should revert to normal function without delay. It should also be possible to carry out the emergency release sequence, emergency release followed by application of brakes, even during a blackout. An appropriate length for the towline should be determined using established criteria. Where no such criteria have been established, the minimum required length of the main towline should be determined from the formula, length equal the continuous bollard pull divided by the documented braking load of the towline, all multiplied by 1800 meters. All the wire ropes used in the tow should have the same lay, right hand or left hand. The minimum documented braking load of the main towline should generally be as follows. If the tug's bollard pull is less than 40 tons, the minimum braking load of the towline should be the bollard pull multiplied by 3. If the tug's bollard pull is between 40 and 90 tons, the minimum braking load of the towline should be 3.8, minus bollard pull divided by 50, all multiplied by the bollard pull. If the tug's bollard pull is more than 90 tons, the minimum braking load of the towline should be the bollard pull multiplied by 2. The towing points are the fittings especially provided for connecting the towline, or wire rope bridle and chain bridle, on the towed object. These include towing eye plates, or towing bollards. The wire rope bridle and chain bridle mean the connection lines used for towing larger objects. The bridle connects the lead line, or chafing chain, from the towing eye plates, or towing bollards on both sides of the towed object, to the delta eye plate. This arrangement facilitates maintaining a steady course for the towed object. Triangle plates, also known as monkey or delta plates, are particularly suitable for towing applications. They equalize the load when using multiple tow lines and prevent the interference of chains, ropes, or shackles during operation. Coupling links, like Kenter shackles, are heavy-duty components that can replace shackles and make the towing job exceptionally easier and more efficient. These links are designed to allow operators to attach links and other accessories to the towing chain in order to increase its holding strength and versatility. A chafing chain is a chain at the end of a towing line, normally guided through a chock at the edge of the bar. Chafing measures should be taken for the towing gear in chafing areas, as appropriate. A short pennant means the cable connecting the delta I plate, or the wire rope and chain bridle and the towline, to the towing vessel. The main towline is the connecting line between the towing vessel and the towed object. For open water towage, the main towline and the spare towline should be wire ropes, and their minimum breaking loads are to be determined by the bollard pull of the towing vessel and the towing environment. For towage carried out in sheltered areas, and when the towing period is less than 24 hours, polyamide rope may be used as the main towline. The minimum breaking load of the polyamide rope should be 1.37 times that of the wire rope. If synthetic fiber rope is used as the main towline, its minimum breaking load is to be 1.25 times that of the wire rope. The towage speed of a towing vessel in static water is to comply with the following requirements. For ship-type towed objects, the towing speed should not be less than 6 knots. For linear towed objects, like a floating dock or a crane barge, the towing speed should not be less than 5 knots. For towed objects like a jack-up barge, the towing speed should not be less than 4 knots. A spare towline satisfying all requirements for the main towline should be kept on board the towing vessel. If the towing winch is equipped with 2 drums, the spare towline should preferably be stored on the winch drum, readily available for use. The alternative is to have a spare towline which should be in position and so arranged to ensure that transfer to the main towing drum is easily, quickly, and safely effected. Towing alongside is considered to be a bread and butter skill for anyone operating a towing vessel. Let's look at the position of the tug. When towing a small barge, like a hopper, the tug's propulsion unit is clear of the side of the barge. The preferred way to tow a large barge is to have the barge's stern pointing in the direction of travel. This configuration allows for better and more predictable handling characteristics when they are cutting through the water. This helps to minimize the effect, where tug and tow travel sideways a certain amount when moving forward. You can counteract this effect with the rudder. In some cases, it can be so extreme that you use up virtually all of the rudder, swung away from the barge side, just trying to go straight. A trick that will often help, when towing anything alongside, is to use only your inboard engine, the one on the side where the barge is made up. Let's look at the rigging of the towlines. The spring line transmits the majority of the forward pulling force of the tug to the barge. The head and stern lines transmit the turning forces that allow the barge to be steered. The head line also handles most of the backing forces. The tug's deck lines can be polyester, it has the right amount of stretch for towing alongside. Nylon is too stretchy, but polyester has just enough stretch, around 5 to 8%, to allow the lines to absorb enough of the forces that are exerted by the independent movements of the hulls of the tug and barge, while not being so stretchy that you feel like a yo-yo while trying to handle the barge. Pinch is the angular difference between the longitudinal center lines of the tug and the barge, when they are made up. Seldom would you ever find the optimal alongside towing makeup to leave you dead flat against the barge. Pinch can vary widely, and there is no one correct answer. A good starting point is to try ending up with the tug's bow aligned with the near side corner of the barge and adjust from there as you experiment to figure out how the barge handles best. When pushing a barge ahead, the use of winches is recommended to ensure that the barge is securely attached to the tug, thereby ensuring that the tug and tow operate as a single unit during maneuvers. The winch wires should be secured to the most outboard set of bollards of any pushed barge or combination of pushed barges. In addition, there should be two substantial lines connected from the barge's port and starboard quarter bollards to the tug's head post, preventing the horizontal movement of the tug across the width of the barge.